Retail store investment project. There are many examples like this. Not just retail store, like gas station or any kind of investment project. So you make the building equipments, you buy the land, then you build it, and then it will generate some cash flow for a certain number of years, and then it will have some value left at the end of the investment or end of the project life. So this is a very typical scenario. And then the question is this project viable at some minimum attractive rate of return, in this case 20%? What is the internal rate of return? What's the present worth? What's the capital recovery or annual worth? Something like that, question like that. So let's go ahead and so here is in Excel, I have extracted all those values from the description. You can go back and check those. So first thing we need to do is to develop the cash flow diagram. So let's write the period and then cash flow. So all the way up to 20 years. So we'll develop the cash flow for 20 years. This project lasts for 20 years. For year 0, we're going to invest all of this money. So, and then year 1, it says it generates the cash flow of this, assuming that the working capital is also within that annual cash flow. Sometimes it is not within the cash flow, assuming it's already in that $2.75 million. So copy all the way down. That's the annual cash flow. Then at the end of the year, we still have some value left, which is these. Yes, I want to add. So that's all the cash flows. Now we can simply calculate this internal rate of return. There is this function called IRR. You just simply select that, and that's the IRR, 20%. So based on the IRR, this project is viable. This is a project that the decision would be, yes, invest on this project. So our attractive rate is 20%. We're going to get more than that. We're going to earn 22% from this project. Now next we can calculate the present worth. So because the IRR is more than the MAR, the present worth will be positive. So let's calculate the present worth. So we can simply type that function called PV, and then the rate is 20%. We're going to freeze that cell so we can use again and again. And basically we are converting each of these cash flow at year 0. That's present worth, all of them. So we're going to use the compounding period. The first cash flow obviously is not going to be compounded because it's sitting at year 0. So all of this, I'm going to keep the same sign. So I'll use a negative sign. All of this future cash flow, we're going to convert it to today's value. So we're going to copy all the way down. So that is the basically at, let me see. Yeah, the interest rate was copied right. So basically at year 19, that annual cash flow worth only $86,000 in today's value. So these are all present worth. So we can simply basically add that column, simply type sum and add this present worth column to get the present worth. So that's the present worth for this project, which is positive. As we know that it's going to be positive because IRR is more than the MAR. Everything else will be positive. If we want to see what will be the future value of this money, we can simply type AV, and then so that's the rate, comma, number of compounding period is 20. I'll just manually type that, and then I'll keep the same sign. So we don't have any payment. We're going to convert the single present worth of this entire present worth is this. So I'll use a negative sign to keep the same sign. So that's the future value of this project. The question was asking annual recovery, capital recovery of the project, which is the payment or annual cash flow, equivalent cash flow for this present worth. So simply rate is 20% again for 20 years. I'm going to use a negative sign. That's the present value of this entire project, and I'm going to distribute that over 20 years, and that's what the question is asking. So that's $250,000 per year equivalent we're going to get from this investment at a rate of 20% MAR.